and then go from there. So I'm going to get a nice picture of an ellipse. All right, so there's our conic section. So we're in section 9.2. So an ellipse, we get an ellipse when we cut through both sides of a cone at an angle to the base. So we get an elliptical shape, kind of like an oval. So we'll call it an ellipse. What we're going to do is talk about our definition of our ellipse, our locus definition, the set of points, and then we're going to write our equation in standard form and figure out what that tells us about the graph of the ellipse and all the special points on our ellipse. So our definition. An ellipse is going to be a locus of points. And again, a locus is just a set of points, locus of points. And our points are x, y, the points on the ellipse, where the sum of the distances from the point to two fixed points, and our fixed points are the foci, plural of foci, is constant. So we're going to add the distances from the two foci, and we get a constant. So let's draw a little sketch here, what we're talking about. So an ellipse is kind of an oval shape. I know my sketch isn't perfect there. And our foci are inside the ellipse. So those are our foci. And we're going to look at the distance from the ellipse to some point on the ellipse, x, y. And we're going to call that d1 and this d2. And for an ellipse, the sum of those distances is constant. d1 plus d2 equals a constant. And our equations are going to come from using the distance formula and saying these two distances from wherever our foci are constant. And everything comes from that idea. All right, are we good? Good so far. So now let's talk about, we need a little bit of vocabulary with our ellipse. So we have a bunch of different pieces. So let me get a picture, and we'll talk about some vocabulary. So there's our ellipse. Your drawing doesn't have to be nice, beautiful, and perfect. We just want to talk about some pieces. So we're going to have a long axis that we call the major axis. We're going to have a short axis that we call the minor axis. And right here in the center is our center. I don't need parentheses now. And we have foci here and here. At the end of the major axis is going to be our vertices. So we have a vertex at each end of the major axis. You'll hear them called the vertex or the major vertex. We usually just call them the vertex. And at the end of the minor axis, we have the co-vertices, or the minor vertex. So the ellipse has 2 foci and 4 vertices that we have to keep track of. But it's kind of nice the way everything works out. The distance from the center to the focus we call C. The distance from the center to the minor axis we call V. And the distance from the center to the major axis we call A. And for an ellipse, A squared equals B squared plus C squared. And we can remember that if we draw a nice little triangle here. Inside the red triangle, this length is C, that length is A, and that length is B. So A squared equals C squared plus B squared. That will help you remember how A, B, and C are related. And A, B, and C are going to be what are important with our ellipse. Like the p-value with the parabola, that was kind of the key value once we found our standard form. For an ellipse, we have three things that we need to keep track of, and this is how they're related. All right, questions so far on our terminology. So what we're going to do is, just like we did yesterday, we're going to talk about our standard form of our equation. We're going to talk about an ellipse with a horizontal major axis and a vertical major axis, and how the equations change with both of those, and what A, B, and C have to do with the equation, and how they relate to our ellipse itself. Okay. So our standard form of our equation. Let me grab a picture. We'll do our horizontal major axis first. Make that a little bigger. So this is just to remind us what we're talking about here. Our standard form for the equation of an ellipse, if we have a horizontal major axis. Our equation is going to be x minus h squared over a squared plus y minus k squared over b squared equals 1. For our standard form, we always want this 1 on the right-hand side. A for an ellipse is always bigger than B. The major axis is always longer than the minor axis. So A is greater than B. So the way we can tell if we have the equation of an ellipse, the way we can tell we have a horizontal major axis, the big number is under the x part. Yes?
What are the values of k?
We'll get that in just a second. So the bigger number is under the x part for a horizontal major axis. Our center is at the point HK. So this is like a circle. The center is at the point HK. With our parabola, the vertex was at HK. So kind of the same thing. Our center is at HK. The major axis length from one vertex to the other vertex is 2a. So it's a units here and a units there. So the major axis is 2a units long. The minor axis, b units here, b units there, 2b units long. So that's what the a and the b values tell us. The a value tells us how far the vertex is from the center, and the b value tells us how far the co-vertex is from the center. And then we can find our foci. Let me do the vertices first, sorry. Vertices, we move from the center a units left and right to get to the vertex. So I'm going to move left and right from the center, h plus or minus a k. The co-vertices, we're going to move up and down from the center to get to our co-vertices, and we move b units, so that's going to be h k plus or minus b. So we're moving up and down from the center, and just as a reminder, a squared equals b squared plus c squared, always for an ellipse. C tells us how far we move from the center to the focus. So we can find our two foci, left and right, c units from the center. So it's going to be h plus or minus c, k. Those are all of our values. The key points here, when our major axis is horizontal, the bigger number, the a, is under the x part. A tells us how far to move left and right from the center to get to our vertices. B tells us how far to move up and down from the center to get to the co-vertices, and C tells us how far to move left and right to get to the foci. Yeah.
How do you know if it's plus or minus?
It's both, because we go plus to get to this one, and we go minus to get to that one. We go plus to get to that one, and minus to get to that one. So if h is 0, if our center is at 0, 0, this point is going to be at, for example, this would be at 5, 0. This point would be at negative 5, 0. No, we're moving 5 units from the center. So the plus is to take us 5 units right from the center. The minus takes us 5 units left from the center. Okay? All right. So we're good with the horizontal major axis. Vertical major axis, basically what we do is switch the x's and the y's around. All right. So let me grab the picture for that. So for our vertical major axis, I'm just going to write things in a different order. We don't have to write it in a different order. But for our vertical major axis, we get y minus k squared over a squared plus x minus h squared over b squared equals 1. A for an ellipse is always bigger than b. So for a vertical major axis, the bigger number is under the y. That tells us that tells us our major axis is vertical. Our center is still at the point HK. And notice that the K always goes with the Y, the H always goes with the X. Our vertices. This time we're moving up and down from the center, since our major axis is vertical, to get to the vertex. So we're going to have our point at H, K, plus or minus A. We're moving up A units and down A units to get to each vertex. The co-vertices. Now we're moving left and right along our minor axis to get to our co-vertices. So it's going to be H plus or minus B, K. And this distance from the center to the focus is C. So our foci, we're going to move up and down C units from the center to get to our foci. So H, K plus or minus C to get our 2 points. And our major axis is still length 2A, our minor axis is still length 2B, and we still have A squared equals B squared plus C squared, always for an ellipse. So again, our key points. Standard form of our equation. We have a 1 on the one side of the equation. The A tells us how far to move from the center to get to the vertices. The B tells us how far to move from the center to get to the co-vertices. C tells us how far to move from the center to get to the foci. So what I want to do is do a couple of examples of kinds of problems you might see. I want to talk about one of the special properties of an ellipse, and then we'll draw an ellipse up on the board. All right, questions? Questions so far? Yes.
So I know this horizontal and vertical.
For an ellipse, A is always the biggest number.
Oh, yeah.
If the biggest number is under the Y part, it's vertical. If the biggest number is under the X part, it's horizontal.
Okay.
And then if they give you, we'll go over some problems where they give us some other things and we can figure it out from the information they give us. All right, so let's look at a couple of examples. We want the center, the vertices, and the foci of the ellipse, and we have 9x squared plus 4y squared equals 36. So is this in standard form? No? What do we need for it to be in standard form? What do we need on this side? A 1. So how do we get that to be a 1? Divide everything by 36. I'm going to divide everything by 36. So I get x squared over 4 plus y squared over 9 equals 1. And now we're set to get all of our information here. First off, the easy one, where's our center for this one? 0, 0, right? Our center is at 0, 0. What's A? A for an ellipse is always bigger. So what's A? A squared is 9, so A is 3. So is this going to be a vertical or horizontal major axis? Vertical, right, because the bigger number is under the Y. If we wanted to draw a little sketch here, ellipses are really easy to sketch. Our center is at 0, 0. A is 3, so we're going to go 3 units up and 3 units down.
Why does A have to move around? Why can't you just control right about it?
Because for an ellipse, A is always bigger. The major axis is always longer. So A is always the biggest number.
Okay, so
The major
I was thinking if B allowed B to become the major axis, why can't you just think about the axis?
You could. It's just we always, the way that ellipses are defined, A is the major axis is always gives us A.
Okay, so it's like the same thing with quadratic. Okay, you want to use A.
Right.
always.
Right. All right. So A is 3. What is B? How long is our minor axis? B is 2. So we could move over 2 units there and 2 units that way. So there would be a little kind of a rough sketch of our ellipse. And so we found our center. We can find our vertices. So we already decided this vertex. We're moving up and down from our center to get to our vertices. So our vertices are going to be at 0 plus or minus 3. There and there. Our co-vertices. We're moving left and right, so plus or minus 2, 0. And the foci, we need to find C. We know that A squared equals B squared plus C squared, always for an ellipse. So 9 equals 4 plus C squared. So C equals square root of 5. So our foci, we're moving up and down. The foci are always on the major axis. Moving up and down C units. So our foci are going to be at 0 plus or minus square root of 5. So we'd be here and here, approximately. So there's our information, and we drew a nice little sketch. If the problem asks you to draw a sketch, that would be fine for a sketch of that ellipse. All right, questions there? Okay, let's kind of work the other direction this time. So what the problems are going to be is some variation of giving you different pieces of information about the ellipse and coming up with either the equation, from the equation coming up with other information. All right, so we want the equation of the ellipse. With the center at the origin. Major axis length 10. And foci at plus or minus 3, 0. So the first thing that I suggest we do, always suggest you do, is try to figure out, is this going to be a vertical or horizontal major axis? So which one is this going to be? Horizontal. And what makes you say horizontal? Foci are symmetrical on either side of the origin on the x-axis. So if you need to, we could draw a little sketch. So here's one focus, and there's the other focus. Those are on the major axis. So the major axis is horizontal. So we know it's going to be horizontal. Our center is at the origin. So part of our equation is going to look like x squared over something plus y squared over something equals 1. Major axis length 10, what does that tell us? Well, from here to here, my other vertex is 10 units. So what does that tell us? A equals 5. So I can put a 25 here. There's a squared. Now we need to figure out b. How do we figure out b? into the equation. What do we have? C? C is 3. Distance from the center to the focus is 3. C equals 3. Plug this into our equation. So we know that 25 equals b squared plus 9. So b squared equals 16. And there we go. We're done. That would be the equation of that ellipse. We could draw a sketch if we wanted. We know this is plus 5 and minus 5. Our minor axis, b squared is 16, so b is 4. So we go 4 units here and here. So that would be 4 and negative 4. And we could draw a little sketch of that ellipse if we needed to. So there's a nice little sketch of our ellipse. So all our problems are going to be some variation on this kind of thing. They'll give you pieces of information, and you just need to figure out the other pieces from what they give you. All right, let's look at one more, and then I want to talk about the properties of an ellipse, and we'll draw a picture. So we want to sketch a graph. Um, 25x squared plus 9y squared minus 200x plus 36y. You see what's going to happen here? Plus 211 equals 0. We want to sketch a graph of that thing. So what do we have to do here? Remember this, we did a circle example and a parabola example that was kind of like this. Complete the square twice. So when you see a problem like this, it's going to be a complete the square problem. We want to complete the square so we can write it in standard form. From the graph, we can get all of our information that we need to write it in standard form. So let's collect the x pieces. And the y pieces together. And put the constants on the right-hand side. Now, before I complete the square, what do I want to do? I want to factor. I want to get these leading coefficients out of here. So I'm going to write that as 25x squared minus 8x plus 9 times y squared plus 4y equals negative 211. Now I'm going to complete the square. So I have 25x squared minus, divide this by 2, minus 8 divided by 2 is minus 4, and we square that. We get 16 plus 9 times y squared plus 4y. Half of 4 is 2. Square that and we get a 4. And that equals minus 211. And what do we need to add to this side to make sure that we keep it? We haven't done anything in the end. 25 times 16, which is 400. And 9 times 4, which is 36. So we're distributing, remembering to distribute the 25 to the 16 and the 9 to the 4. So I get 25x minus 4 squared plus 9y plus 2 squared equals 225. All right, and to get it into standard form, what's my last step to get it into standard form? I want a 1 here. So divide everything by 225. So I get x minus 4 squared over 9 plus y plus 2 squared over 25 equals 1. Yeah. So when I've divided everything by 225. So 225, or 25 over 225 reduces to 1/9. 9 over 225 reduces to 1/25. So I just reduced those fractions. All right, now we're ready to sketch our graph. We have the information that we need. Where's our center? 4, -2. So if I drew my graph over here, the center would be at 4, -2. So there's the center of my graph. What is A here? A equals 5. So that tells us our major axis is going to be vertical. B equals 3. So to sketch our graph, all I need is to sketch the ends of my vertex, my vertices and my co-vertices. So I go from my center, I go up and down 5 units to get my vertices. So this point would be at 4, and I go up 5 units, 3. Go down 5 units, so this point would be at 4, -7. And I move left and right 3 units from the center to get to the co-vertices. So this would be at 7, -2. And then I'd have a point over here at 1, -2. And then I could sketch my graph of my ellipse. So there would be a sketch of that graph. All right, questions on that example? Yes? Because the bigger number was under the Y. The bigger number is under the Y, it's vertical. Under the X, it's horizontal. Okay. One other thing about ellipses that the eccentricity. E is C over A. And C over A, the eccentricity for an ellipse, is between 0 and 1. And that tells us how close or how far away from being a circle our ellipse is. So if the eccentricity is close to 0, it's almost a circle. So that means the foci are really close to the center. So we can think of a circle as an ellipse with both foci right at the center. And this is really stretched out. So our ellipse would look like that. So the foci are really far away from the center. So sometimes in some problems you might be given the eccentricity. Just remember the eccentricity is C over A. And the reflective property of an ellipse. If you have a room or some walls, a ceiling, that are in the shape of an ellipse, and you stand at one focus and you talk, the sound is reflected right to the other focus. So I think it's in the National Gallery, there's they call it a whispering chamber that's in the shape of an ellipse. If you stand at one focus and someone is across the room at the other focus and you talk in a really soft voice, it sounds like they're right next to you. I was at the University of Nebraska. I went to a workshop there, and they have a sculpture, a piece of art, that's 2 big pieces of steel that are in the shape of an ellipse, and you walk in between them, kind of like this. And if you stand at a focus, and another person stands like 10 feet away at the other focus, you can turn your back, and you can whisper, and they can hear you. It's pretty cool. All right, questions on the ellipses? Okay, let me write the homework up on the board, and then we'll draw an ellipse. And what I suggest on these is, just so you can savor some math every day, is divide it out so you can do like 2 or 3 problems every day. That sounds like a good idea to me. What's that?
You don't want to go a day without pre-calc.
That's right. A day without math is like a day without sunshine, and a day without sunshine is like night. Some students said in the other class, they said, "Why is there so much?" And I said, "Well, you guys have a week."